Hello everyone, I'm very Clements from Agriculture Mechanization. Here I have the 43 topic of agriculture ergonomic. The comprehensive overview of such three topic is the talk about the covering posture, vibration, surface, design, technology, and operator health in modern and traditional farming environment. The first topic is about the operator posture analysis in tractor driving. The first one about the operator posture is tractor operators often they maintain static awkward posture for hours, pressing sustainable load on the lumbar, spine, shoulder, and the necks. The second one is the frequent twisting and lateral bending occur when the checking implement, reversing or monitoring follow lines, increasing the injury risk. The third one, posture analysis tools such as labor hours ruler are used to quantify risk levels, identify priority bodies region for the intervention. The ruler means the rapid inter-body assessment, while ours it means the overall working posture analysis system, and the ruler means the rapid upper limb assessment. The fourth one is corrective measures include the adjustable seating, steering column, tilt, and the designed mirror placement to reduce compensatory postures. Field studies show that to improve curb ergonomics can reduce the musculoskeletal discomfort scores by up to 35%. The higher there are listed some risk factors. The first one is static lumbar loading. Second one, neck flexion greater than 20 degrees. The third one, shoulder abduction. The fourth one is prolonged seat pressure. The last one is vibration compound. The second topic is about the design of ergonomic control panel for farm machinery. The first one about the design of ergonomic control panel is control panel must be arranged according to the frequency of use and the importance principle, pressing critical control within the primary reach zones. The second one is the poor control placement forces acquired reaches that compound vibration, exposure, and posture strain during the field operations. The third one is color coding, tactile differentiation, and logical grouping reduce cognitive load and prevent accidental activation of the function. The fourth one is modern touchscreen panel must be designed for use with glove hand in vibrating dust high glare condition. The last one, user-centered design process including participatory ergonomic control panel suite the diverse range of operators in the practice. Here there are some principles you can according it when you are designing farm machinery tools. The first one, primary reach zone based on Oracle 14 centimeters. The second one is groove compatible control. The third one, high contrast labeling for fan anti-glare surface. The last one, logical function grouping. The third topic is about visibility and blind spots in agricultural vehicles. The first one about visibility and the blind spot in agriculture is tractor and the combine harvester have significant blind spot due to large engine supports, roof pillars, and touched implements. The second one, blind spot, increases the collision risk with the pedestrian, animal, and other equipment, a major cause of farm fatalities. The third one, structural visibility assessment, use international standard 5006 standard to map operator field of view and identify unacceptable blind zones. The fourth one, camera-based and radar proximity system and keys integrated to supplement direct operator vision. The last one, curb roof design, mirror geometry, and window glazing angle are key engineering levels for improved all-around visibility. Here there is some solution about the visibility and the bright spot in agricultural vehicles. The first one is 316 degrees cameras system. Use international standards 3006 compliance. The third one, optimize the pillar design. The fourth one, proximity sensor. The last one, convex mirror positioning. The fourth topic is said about the usability evaluation of multi-function joystick control. Modern farm machinery consolidates many functions into a single multifunction joystick, reducing hand travel but increasing the cognitive demand. Second one, power mapping between joystick movement and machine action can lead to the error, especially under the time pressure or fatigue. The third is usability evaluation. Think allowed protocol task compression, rates, error logs, level design, defenses in real operator condition. The fourth one is grip forces, waist deviation, and thumb each distance are key anthronometric constraint in joystick ergonomics. The last one is haptic feedback and programmable button assignment can significantly improve the operator accuracy and learning time. Here there is some usability metrics. The first one is the task compression rate. Second one, error frequency. The third one is cognitive load. NASA TLX. This means the about the 5 topics is whole body vibration exposure in tractor operators. The first one about whole body vibration is whole body vibration. First of all, whole body vibration is transmitted from train through the tractor chassis and seat to the operator spine, affecting the lumbar and thoracic region most severe. The second one is European Union Directive 2002/44 and European Community set an action value of 0.5 meter per second square and an exposure limit of 1.15 meter per second square daily per A8 for all body vibration. The third one, field studies show the most tractor on rough terrain exceed the action value, putting long-term operator health at the risk. The fourth one is chronic whole body vibration exposure is linked to low back pain, disc degeneration, and the sciatica condition common among aging farmers. The last one is active and passive suspension system for both set and curb can attenuate whole body vibration by between 13 and 60 percentage depending on the design quality. Here there is health effect. The first one is low back pain. The second one is intervertebral disc damage, sciatica, fatigue, and sleep disruption. The last one is digestive disorder. Sixth topic is said about the city design optimization for long duration field work. Agriculture city must be provide the adequate lumbar support, vibration isolation, and the adjustability across the wide anthropometric range of the operator. Suspension travel, natural frequency, target less than 1 Hz, and the damping ratio are critical seat design parameters for all body vibration mitigation. The third one is seat pan angles, damp and firmness affect the pressure distribution on the ischial stability during prolonged sitting. The fourth one, active air suspension seat, adapt in real time to train roughness, providing superior comfort compared to the passive spring. The last one is armrest integrated with control levels, reduce shoulder effort, and the dynamic instability during the rough terrain operators. Here there is some parameters you can accordingly to when you design something. The first one is suspension on natural frequency less than 1 Hz. The second one, lumbar support curvature. The third one is seat pan tilt adjustment. The fourth one is armrest height and width. The last one is vibration isolation efficiency. The seventh topic is said about the manual handling risk in small scale farming tools. The first one about manual handling risk is said small scale farmers rely heavily on manual tools such as hoe, sickle sprayers. These all exposing them to repetitive, awkward posture and high forces demand. The second one is backpack sprayer used improve symmetric load bearing of between 15 and 25 kg, causing significant spin and shoulder loading. The third one, tasks like hand winding, planting, harvest involve the prolonged stopped posture. Reading caused the chronic back pain in rural communities. Here I have the fourth about manual handling risk is NIOSH, that means National Institute for Occupational Safety and Health. Lifting, equation and labor, that means rapid interbody assessment. High numerous manual handling task has high risk in smallholder farming context. The last one is lightweight material, extended handling, and ergonomic grip design can substantially reduce manual handling injury risk. There is some most common risk that is manual handling can cause in small scale farming. The first one, hand weeding. Second one, backpack spraying. Third one, bag sack hauling. Fourth one, manual harvesting. Last one, transplanting seedling. The eighth topic is musculoskeletal disorders among farm machine operators. Musculoskeletal disorders are the most prevalent occupational health problem among agriculture machinery operators globally. Second one, common conditions include low back pain, shoulder impairment, knee osteoarthritis, and carpal tunnel syndrome. The third one, risk factor include prolonged sitting or body vibration, repetition in motion, awkward posture, and higher grip force on the control. The prevalence studies in Europe and Asia report that between 50 and 80% of tractor operators experience regular musculoskeletal discomfort. The last one, ergonomic intervention, targeting design, control layout, and work rest scheduling can reduce musculoskeletal disorders incidence significantly. Common musculoskeletal disorders are low back pain, shoulder impairment, knee osteoarthritis, neck pain, stiffness, carpal tunnel syndrome. The ninth topic is said about ergonomic factor contributing tractor rollovers. Tractor rollovers account for over 14% of tractor-related to fatalities worldwide, making rollover prevention an ergonomic and safety priority. The second one, operator perception of slope angle is often inaccurate, particularly when fatigued or when working within unfamiliar terrain or implement. Curb design that resists the view of the front wheel and train ahead disagrees the operator ability to anticipate roller condition, roller protective structure, and seat belt are essential, but comfort and visibility must be maintained to ensure the compliance. There's an auditory and a visual slope warning system that alert operator when surface remains appropriate, increasing the incorporated in modern tractor. Here there are some prevention measures such as roller protective structure installation, seat belt use and enforcement, slope warning alert, operator training, weight distribution guidance. The 10th topic is about design of sofa entry, exit system, steps, ladders, and handhold. Fall during mounting and dismounting from tractor and harvester are significant cause serious farm injuries, particularly in order to operators. Second one, step height, depth, and slip resistance are critical dimension parameters governed by International Standards 2867 and ASEBO Standard 3-point contact 2 hand and 1 foot or 2 feet and 1 hand is recommended technique required handling at appropriate positions. Entry existing system on modern combine can involve between 1.5 and 2.5 meter for vertical travel, making handrail continuity essential. The last one is model or ice condition dramatically increase slip risk, making self-cleaning, treated pattern, and texture grip surface critical design feature. Here there are some design standards. The first one, the National Standard Organization 2867 step dimension, max step rise less than or equals 300 mm, hand odd diameter between 25 and 45 mm, slip resistance treated rating and entry point. The 11th topic is about fatigue and its effect on machine operated shafts. The first one, farming involved long irregular work hours, especially during planting and harvest season, leading to acute and accumulating fatigue. Fatigued operator show the slow reaction time, reducing vigilance and impaired judgment, increase the risk of accident and equipment damage. The second one, physical fatigue from all body vibration, awkward posture, and exertion, compound mental fatigue from the sustained attention and decision-making demand. The fourth one, field studies show a sharp increase in operator error rates after between 8 and 10 continuous hours of tractor operation. The last one, schedule breaks, task rotation, and curb comfort improvement are primary fatigue management strategies in agriculture operators. Here there is some fatigue indicators. The first one is eyelid dropping, second one microslip episode, third one increase error rates, fourth slow reaction time, the last one reduced steering precision. 12th topic is about noise exposure and hearing protection, agriculture environment. Tractor and machinery noise level typically range from between 25 and 105 dA in the operator zone, where above and 1685 dB action level The second one, chronic noise exposure, causes noise-induced hearing loss and permitted and prevention occupational health condition. Third one, curb enclosures with acoustic insulation can reduce operator noise exposure by between 15 and 25 dB compared to open platform operation. The fourth one, hearing protector earplugs provide additional attenuated but may impair communication and situation awareness. The next one, older tractor and machinery route included the curb pose the greatest risk. Retrofit solution include the acoustic lighting and the noise isolating headset. Here there is some noise limits. First one, action level, such as action level 85 dBA. Second one, limit values. The third one is tractor between 90 and 105 dBA typically included the curb radar automatic screen. The certain topic is about mental workload in operating modern precision agriculture system. Here the first precision agriculture integrated GPS guidance, vibrate application, yard mapping, and the telematic dramatically increase operating information load. Second one, operator must be simultaneous manage feed navigation system, alert data input and equipment monitoring, training, cognitive resource. Mental working shift is using tools like NASA, TLX, do you task performance and physiological measure, heart rate, variability, and the EEG. The fourth one, automatical and routine subtask, styling rate adjustment, free cognitive capacity, and and requires operators to mainly vigilant for a system failures. Interference design must be balance information richness within the cognitive implicity, avoiding data overload while preserving situation awareness. Here there is workload dimension. First one, mental demand, second one, physical demand, third one, temporal demand, fourth, performance effort, the last, frustration levels. The 14 topic is about interface design for the GPS guided farming equipment. GPS guided system display the field maps, guidance lines, application erects, and machine status on the monitor requiring clear, legible layout. The second one is gyro vibration and data grooved hand and measure usability challenges for touch screen interface in agriculture cabs. The third one is guidance line within the car contracts and update frequency, effect operator steering precision, field covering efficient, auditor guidance, course direction, tones, voice and prompt, reduce visual demand and allow operator to maintain eye contact within the surrounding. The last one is constant iconography, intuitive manual healers, and the minimal tap workflow are essential for usability by operator within the varying digital literacy. Here there is the some best practice. So the first one, high contrast display, mini font size 14 pt, voice guidance, global compatible touch and offline capacity. The 15 topic is about alarm system and operator response effectiveness. Farm machinery generation, numerous alarm, hydraulic pressure, temperature gain, tank, fluid codes, requiring operator discrimination and response. alarm flooding, too many simultaneous unnecessary alert cause operator suffer or ignore one, increasing the accident risk. Alarm priority, critical warning advice must be clear, differentiate through distinct auditory tones, color, and display positioning. Response time, critical alarm is degraded, fatigue, noise masking, and high complete workload, all common in field operator. The evidence-based alarm relation follow international standard against 18.2 principles can reduce nuisance harm by over 50% in precision agriculture system. Alarm design rules, priorities of severity, avoid alarm flooding, distinct tone per level, separation tracking, operator acknowledgement logging. 16 topic ergonomic of autonomous and semi-autonomous farm machine. Autonomous and semi-autonomous system transfer physical driving task to automation, changing the operator role into one of supervision and exception handling. Second, the supervision role demands sustainable vigilance. Operator must detect failure system fail in an otherwise monitoring environment. Human automation trust calibration is critical. Variance leads to complacency, while under the variance negative automation benefit. The fourth one, remote operation center produce new ergonomic challenge, including desktop, workstation posture, multi-screen management, and latency effect. The last one is emergence override control must be designed for rapid and ambiguous activation under the time pressure and the stress. Here there is a new challenge, violence, discriminant, comparisons, risk, remote operator fatigue, override response speed. The last one, situation awareness loss. 17 topic is wearable technology for monitoring operator health and fatigue. First one, wearable devices, smartwatch, chest strap, headband can monitor heart rate, HRV, skin temperature, and brain activity to detect fatigue. Inertial measurement units MIUs embedded to fats or all bait quantify posture movement and exposure harmful vibration. In the real time, continuous data stream from the wearable enable practice fatigue alert, prompting operator to take breaks before performing the grades. The previous conflict, battery life, and interference with PPA are practical barriers to widespread wearable adoption in farm environment. Machine learning algorithm trained on physiological wearable data can predict operator fatigue state with over 85% accuracy in the search setting. Monitored parameters: first one, heart rate variability, posture and movement, skin temperature, galvanic skin response, based on alternaces. 18 topic is the about smartphone app for improving farm worker ergonomic. Smartphone app can deliver ergonomic guidance, posture assessment tools, micro break reminder, and training modules to farm workers in the field. Camera based on the pasture analysis app uses to pose estimation, artificial intelligence to access body alignment during manual tasks and provide real-time collective feedback. App can automate exposure, manual handling, risk factor, and generate safety reports for supervisor or occupational health practitioners. User acceptance influenced by literacy level, language barrier, internet connectivity, and digital device familiarity. particularly in a small world context. The last one is gamified economic app that rewards certain behavior have shown promise in motivating behavior change in young agricultural workers. There is app features. The first one, pause estimation, artificial intelligence, micro break reminder, exposure logic, train modular, multi-finger interface. The 19 topic is about ergonomic challenge in smaller bite-sized scale mechanized farming. Smallholder farming rely on the primal manual labor and simple implement, creating higher physical workload and mesosphere disk risk from repetitive manual tasks, large-scale mechanization, farm transfer, physical load machinery that introduce the whole body vibration, extends sitting and cognitive demand of precision systems. Small context culture practice to available and economic influence shape exposure pattern in a way that differentiates from the seal farming. The economic intervention must be context specific, low cost tool, designed behavior training for small car, big interface, and automation improvement for large-scale operator. The last one is bridging the gap before participatory research method that embed local knowledge to co-design solution with community. Contrast smallholder, high manual load, mechanized whole body radiation plus cognition, cost constraint differ, literacy training gap, culture tool and preferred. 20 topic is about climate, heat, dust effect on operator comfort and performance. Agricultural work is performed extreme thermal environment from tropical heat exceeding 38 degrees Celsius to cold mornings require layered clothing that restrict movement. Heat stress impair cognitive performance, reaction time and physical endurance, increasing accident risk and reducing productivity. Dust exposure coupled without adequate filtration, causing respiratory disease, eye irritation, and reduced visibility, or ergonomic performance factor. Climate control system with effective particle filtration ISO are essential. Ergonomic prevention for closed machine operator in pen cab or open field sitting near the administrative control shift timing, shift hydraulic station, and appropriate PP for climate protection. Environment hazard. First one is heat, stress, dust, ultraviolet radiation exposure, cold stress in winter, high humidity, and sweating. 21 topic is about ergonomic redesign of hand-operated agriculture tools. Traditional hand tools like hoe, sickle, and dibber are designed empirically, often resulting in grip and handling angles that cause joint strain. Ergonomic redesign focus on neutral waist position, appropriate grip diameter between 30 and 40 mm for power grip, handle length, and weight distribution. Covered often handle to hoe and sickles can reduce waist and ear deviation and shoulder abrasion. Field interior is designed to constant report to reduction in task compression, time perceived exert, and MCD symptom survey. The first, we have the design target. The first one, grip diameter, neutral waist alignment, balanced weight distribution, non-slip surface finish, reduced tool weight. 22, anthropometric construction in designing farm machinery for different populations. Farm machinery is predominantly designed using European or North American anthropometric data, making it poor suited for operator in African, Asia, and Latin American. Stature, limb length, grip breadth, and reach dimension vary significantly across the world population. Effective control reach can be ingress and seat belt fit. Design should do accommodation on 5th and 95% range of the target operator population, not a single average user. Accommodation strategies include adjustable seat, sliding column, and armrest position, covering a wider range without custom manufacturing. Regional anthropometric database example for South and Southeast Asia, farmers are being developed and improved design specific quality. Accommodation strategy designed for P5 and P25 range, adjustable component, regional data requirement, multiple seat position, sliding column, tilt. 23. Evaluation of control. Such robot in a combine harvester. Combine harvester can control the complex array of comfort. The control reach analysis uses three-dimensional digital human model and physical markup to identify control outside the comfortable reach. Poor control layout order combine forces, operator twist, run or strength, compounding vibration, exposure and fatigue during the harvest. Reach zones, primary, secondary, tertiary, avoid behind access across. 24. Design diverse machine to accommodate diverse operator board size. Adjustable is the primary, that is accommodation anthropometric diversity without requiring population-specific machine via here. There is key adjustment. First one is for the greater than or equal 350 mm travel, height greater than or equal 75 mm range, steering tilt 20-degree range, the lumbar support position, and armrest height and pivot. The 25 heat stress management strategies for machine operator. Machine operator in tropical and subtropical region face significant heat stress risk if all body value exceeds 30 degrees Celsius in carb environment management. Here see the first one engineering, second one scheduling, third one shed and hydration breaks, fourth one cooling, third one heat readiness monitoring. 26. Long-term respirator dust. Its ergonomic implication. Agricultural dust contain mineral particles, pesticides, residual, pollen, mold spores, and toxin, each with distinct respiratory and demand health impact. Here there is some dust health effect. First one, occupational asthma. Second one, oddities episode. Third one, chronic bronchitis, eye, skin irritation. Last one, reduced curb visibility. 27. Impact. Prolonged sitting device standard in farm operation. Some impact about the health from the prolonged sitting. First one, lumbar disc pressure. Second one, reduced growth blood flow. Third one, cardiometabolic risk. Fourth one, hip flexor shortening leg edema. 28 is about gender-sensitive ergonomic design of agricultural equipment. Here there is design gaps, shorter reach distance, smaller hand dimension, greater grip force capacity, PPI not gender-sized under presented in data. 29 topic is about accessibility challenge in elder farmer using machinery. Here we have some related challenge: reduced grip strength, reduced grip decreased flexibility, slower reaction time, visual, stricter deadline, cognitive processing speed. The 30 topic is the relationship between ergonomic improvement and farm productivity. Here there is some productivity gain step. First one, fatigue, injuries, error, stop. From the bottom is food quality, availability, accuracy, RA positive in between 2 and 3 years. 31. Ergonomic design of foot control pedal in tractor harvesters. Pedal parameters, max activation force, pedal spacing, footrest adjustment, pedal anti-slip surface, vibration isolation, and base. 32. Impact curb layout operator efficiency and comfort, layout priorities, control within the reach zone, and structure forward view, HIVs, directed optimated, easy, inter, aggressive, path, and emergent exist axis. Hub layout determine the spatial relationship between operator seat control, display window, HIs, HVS, outlet, or critical ergonomic variables. 33 is about redesigning traditional farming tools using ergonomic principle. Traditional tools like this plough, crop, seed, and backpack sprayer have evolved through culture, practice, not biomechanical analysis. Here there is summary design process. First one, baseline task analysis. Second one, MEG posture measurement. Third one, prototype development. Fourth one, field trial feedback. The last one, final validation rollout. The 34 topic is about ergonomic hydraulic control system in agriculture. Hydraulic system control critical function implemented in lift, head, steering assistance, and braking, making their control soft critical ergonomic. Control requirement: max lever force less than or equal 50 Newton proportion, tactile feedback, detent position on preset, thermal shading online, programmable response curving. 35 effect of uneven terrain on the operator posture and fatigue. Uneven terrain create continuous lateral and longitudinal tilt, forcing operator to make constant posture correction to maintain balance and visual fixation. Terrain effect: whole body vibration by up to 3, reactive muscle to activated hyperactive fatigue, reduces silent perception, increases risk. The writing condition: day-night work and operator performance. Modern farming leasing extend into night hours due to climatic conditions, market demand, and availability of global position system guided automation operation. Lighting standard: forward light less than or equal 1000 lux, cab interior non-glare, perimeter surface lighting, display screen dimming, red over hydrogen efficiency. 37 is about ergonomic challenge in operating machine during rainy in or muddy condition. Wet and muddy condition, degraded friction on control surface step and perform dramatically, increasing slip and fall risk. Risk factor: reduced surface friction, impaired visibility, disaggregated tactile control, muddy contamination of control, cold wet PPI burden. The 38 role of ergonomic training in reducing farming injury. Ergonomic training program teach operator recognize risk factor, adopt soft posture, use equipment adjustment, and report discomfort here. Terrain alone has limited effective without concreted engineering improvement. Behavior change is most durable when the environment supported. Effective training: participatory approach, toolbox, talk, management commitment combined with engineering, regular refreshers. 39 topic is about the evaluation of operator to poor designed machine. When machine is poor designed operator develop compensatory behavior, running, gripping harder, using weight as tool to accomplish tasks. This adaptive may be effective short-term, but improves chronic biometrical loading that accumulation into MCDS over the month of years. Behavior patterns, pain normalized, compensatory posture, workload, and cloning to misuse, delay injury, and reporting. The fourth topic is about the development of ergonomic assessment tool for agriculture tasks. Agriculture ergonomic assessment present unique challenge, outdoor setting, variable tasks, seasonable intensity, and diverse equipment type. Assessment toolkit is a Kereba, Ruler, OWAS, Nairobic MCD, Rationia, accelerometry, all body vibration, surface, MH, video plus artificial intelligence posture analysis. 41 is about ergonomic design of machinery maintenance tasks. Maintenance tasks require access to service point, engine, filter, lubrication, hydraulic, that are often located in a component backward or relevant position. Service access design are the following: group service point, tool-free access panel, adequate clearance, greater than or equal 400 mm, step hand hold at 8 color code by intervention. 42 is about impact of personal protective equipment on comfort and operator performance. Agriculture personal protective equipment include respirators, hearing protection, soft spectacles, gloves, protective clothing, and soft footwear, and influencing operator ergonomic. Personal protective equipment trade-off protection with dexterity, health burden, physical coverage, vision, spare eye, surfeit, hearing loss, awareness, fit for diverse body sizes. The last topic is about ergonomic consideration in transporting agricultural machinery on public roads. Road transport of tractor and self-propelled machinery require operator to transition between field and road driving model, changing control demands and posture need at road speed. Vibrating characteristics differ from field operator. Curb noise increase due to wind and transmission load, raising communication demand. Visibility is critical on public road where other road use may not anticipate with slowly moving agricultural vehicles. Operator fatigue accumulated during preceding field operation directly impairs road driving performance. A major public concern, a clear dashboard, indicators for good modern configuration, right beacon, speed limit, compliance, combined with ergonomic cam design, support, safari support. Road safety factor are the following: speed restriction, compliance, adequate road lighting, amber beacon activated, rear visibility cameras, driver fatigue management. Thank you. That is